next theorem, this is part B of the video of section 11.1 concepts, theorems, and some examples. This is part B. Earlier we saw the definition of sequence and what are a few ways of representing a sequence, how to find out the nth term, then what do you mean by a sequence being convergent or divergent? Now, this theorem, we are going to state that if limit is n approaching infinity, limit is x approaching infinity of fx equal to L, and if you plug in n in the place of x, f of n equal to a sub n. But if I plug in for x, and if I get the nth term of the sequence, when n is an integer, then limit of the nth term would also be the limit of the function L. So this idea will be used quite often in some problems where you cannot see the limit of the given sequence. When you say sequence, there are discrete values. So you have n equal to 1, there is a value. For n equal to 2, there is a value. There is no value bit for n equal to 1.5 or n equal to 1.7 or something like that. They are all integers. So corresponding values are all discrete. So function is a mapping from the set of integers. The domain is a set of integers. So sometimes it is hard to get the limit of the given sequence. So what we do is you find out the relating function uh, by substituting the variable x equal to n. If you get the nth term of the sequence, then the behavior of the function is the behavior of the sequence. So we sometimes find out the limit of the sequence by analyzing the behavior of the function, relating function. So in this picture, you notice that the function f of x approaches the limit L as x approaching infinity. Then if you have the nth term of the sequence aligning with the nth, if you plug in x equal to n, if it gives you the nth term of the sequence, then you can also say the sequence is also approaching the same limit. In particular, since we know that limit is x approaching infinity, 1 over x to the r equal to 0, 1 over a large number, when r is more than 0, this you did in calculus 1 class and a limit section, then we have limit is n approaching infinity, 1 over n to the r will also be equal to 0. So here you notice that this is x here and this is n here. So by replacing x by n, if you get the nth term of the sequence, then you can derive conclusion about the limit of that sequence by looking at the limit of the given function. This will be used in several problems. The next definition is about if limit is n approaching infinity of an equal to infinity. If the limit of the nth term of a sequence is infinity, then this means that every positive integer m, for every positive integer m, there is an integer n such that if n is more than n, then an will be more than m. So this is what you mean by actual definition of the limit when the limit is equal to infinity. It's a very large value. If limit is n approaching infinity of an equal to infinity, then the sequence an is said to be divergent, but in a special way. We say that sequence an diverges to infinity. There are some limit laws here, limit laws of sequence. If sequence A and sequence Bn are convergent, we know what we mean by convergence is. So that means a limit as n approaching infinity of An exists, and similarly limit as n approaching infinity of Bn also exists. If sequence An and sequence Bn are convergent sequences, and C is a constant. Then limit is n approaching infinity of an plus bn is limit of the first sequence plus limit of the nth term of the first sequence plus limit of the nth term of the second sequence. So limit is n approaching infinity an minus bn is limit is n approaching infinity of an minus limit is n approaching infinity of bn. So it's kind of distributing the limits. Limit of constant multiple of an, constant can be taken out of the limit. The c times ln limit of an, then approaching infinity. Limit is n approaching infinity of an times bn is limit of an times limit of bn. It's a product. Is product of limit of the product is product of the limits. Same way, limit of the quotient is quotient of the limits, provided the denominator limit is not equal to 0. Then limit of a constant is always constant because it has got nothing to do with n. Then limit of an to the power p is you can take the limit inside of an and then take the exponent p. This idea is also very helpful in some problems. If p is more than 0 and an is more than 0 as well. What is squeeze theorem? Again, this might sound familiar to you when you did calculus 1 class where we applied squeeze theorem to find the limits of certain functions. So if bn, nth term of a sequence with the nth term being bn, lies between an and cn for n more than or equal to n0, n sub 0, and limit is n approaching infinity of an and limit is n approaching infinity of cn are both L. That means this end and this end both are approaching L as n approaching infinity. Then the middle one has nowhere else to go. It is getting squeezed between two sequences, one lower, one upper. Imagine it is sandwich. So you have vegetable dot cheese in between two bread slices, imagine. So you have the top one approaching the limit L, the bottom one approaching the limit L. The middle one is nowhere else to go but to the limit where the end sequences approach to, which is L here. The limit is n approaching infinity of Bn would also be equal to L. Be equal to L. In this figure, you notice that you have the middle one, which is Bn, the lower one is the sequence An, the upper one is the sequence Cn, and we have upper one sequence Cn, the lower one sequence An, and the middle one is the one that is getting squeezed between An and Cn because the bottom sequence and the top sequence, the lower one and the top one, are all approaching the limit L, then the middle sequence has to approach the limit L. Certain times, it may not be possible to find the sequence, limit of the given sequence directly, but if you are able to set up this kind of three-sided inequality, that we are able to make the given sequence nth term to lie between the nth terms of two other sequences, and if you are able to show that the n sequences, so the left end and the right end of that sequence, an and cn, approach a certain limit, then the middle one will automatically approach the limit L. So this is sometimes very handy to find out limits of certain sequences. This is squeeze theorem, or sometimes called sandwich theorem. So there is one more theorem here. If limit of the absolute value of the nth term as n approaching infinity equal to 0, then limit of the nth term equal to 0. Find limit as n approaching infinity, n over n plus 1. We already did this one in a different, we actually showed this problem. Limit as n approaching infinity, n over n plus 1, we can divide the numerator and the denominator by n. So we get limit as n approaching infinity of 1 divided by 1 plus 1 over n. Is 1 over n equal to 0 because n is approaching a large number. 1 over a large number equal to 0. So this is equal to 1. The limit is equal to 1.